Oh, great, thank you, Adeline. Sorry, everyone. Hopefully the last technical hitch of the day. Some quick notes on using the webinar interface. The main one to point out here is that you can submit questions at any time in using the chapter question box, as you can see. At the end, we will try to address as many of these as we can. So do submit them at any point during the proceedings, and we will also try and follow up with any that we don't have time to reach today. And some commonly asked questions. Yes, the slides will be available for purchase, and the event is being recorded. You'll be sent a link for both of these options within the next few days. We'd now like to go to the first of our polls of the day. These are important to us to understand what are the concerns of the audience and try to fit what we're talking about with what you're interested in. So we'd like to get to the first one, which is looking at the reasons for deploying small cells. Adeline will run that.
So I did push the poll here. So what do you think is the most important reasons for deploying small cells? Just take a few seconds to answer between the different answers offered here. I'll be waiting a few more seconds to close the poll. So we have still people voting. Okay.
See quite a clear consensus on this one, actually, unusually enough.
And let me close the poll and share the results.
So definitely 2/3 of the audience are seeing the main primary reason as being as a vital element of offloading data from the mobile network. Excuse me. But also others looking further ahead and seeing it as a step towards the HETnet. And that's an interesting point which I hope to bring out now in my own very short presentation, where I'll just highlight a few key findings from our recent research, but certainly the general issue of moving towards the HETnet, something that will happen in slow stages, is dominant in when we talk to carriers around the world, as we do in depth, and we track the top 100 deployers of 4G networks around the world. So we have several reports coming out based on the latest findings from this in-depth studies, and I'll share just a few highlights to give you a flavour of what's coming up. And I hope also they will tie into what we hear from Tao later on. So first of all, as I've just said, HETnet will not happen overnight. It's not a big bang. It's something to which operators are moving step by step, hoping eventually to achieve a sort of pool of spectrum and capacity that is software driven, that is flexibly deployed wherever it's needed on a dynamic basis. So it's very much started with early deployments of small cells and with offload to Wi-Fi. These are very useful applications, as the poll just sort of indicated, but the full potential of these architectures is so far very far from realized. And we believe there are three key catalysts which will lead these early steps towards the full flexible HETnet. Those are full integration of Wi-Fi into the mobile carrier network, full interworking between the cell network and the macro layer, and the deployment of LTE advanced, or at least certain features of it. The first step towards this then is creating a single small cell layer. For most operators, they will start by creating their small cell layer separate from the macro and sort of address full interworking at a later stage, often enabled by new standards. So first looking at integrating various spectrum and technologies into that small cell layer. Oh, I apologise. Including Wi-Fi. There have been very important steps forward in this particular work, standards like next generation hotspot and passpoint, which are enabling seamless handoff between Wi-Fi and cellular. Now we're moving to management from common mobile calls and to single sites where Wi-Fi Wi-Fi and cellular coexist. In some cases, although this is sort of controversial, in a single unit, some don't see the need to get down to integration right at chip level. Others do, so I think that's one still up to date. But as we can see, the impact just in the sheer numbers, by 2018 we'll see over 9 million sites deployed, which give operators access to cellular and Wi-Fi. Those may be separate, they may be NGH-enabled Wi-Fi hotspots, but this is a huge pool of capacity being added to the relatively smaller rollout of cellular-only metro cells. So we do see integration of these two technologies as being key. The next step then, very important to bring the full capacity potential, is to evolve the macro layer. And of course it's a myth that the macro layer is being neglected while everybody runs to small cells. It's important that the macro layer also changes architecture, and in some ways it's doing it even more dramatically, particularly two key trends in thinking. Cloud RAN, where the network is fully distributed and all the baseband processing, or most of it, is virtualized in the cloud. And the super macro, which it appears to be the opposite, and that means building up certain macro sites with technologies like 4x4 MIMO and even beyond, very advanced antenna technologies. However, these two are not necessarily an either-or. Some operators are looking at a combination of both, and often with some of the super macros serving as sort of master sites for a large number of very low-cost small sites within the macro layer, which will, in many cases, just be running an antenna. We sort of see an evolution almost of the DAS architecture coming out here. There are some very sort of pure examples, and China Mobile has one of their Cloud RAN project, but we believe that most operators will go for hybrids, where they introduce various elements of these architectures in various locations where needed, and will rely on some of their specialized chip architectures and their DSPs and so on, really for quite a long time to come, even as they virtualize and centralize a lot of their activities. But the most important trends, increasing offload, super sites, and COMP, coordinated multipoint, a lot of operators say that this is the main aspect of LTE Advanced for which they are interested in distributed networking. It greatly improves cell site efficiency and how capacity is deployed flexibly. So we can see from the graph, this is looking particularly at Cloud RAN. In numbers terms, the Cloud RAN sub-sites, the little cut-down antenna sites at the edge of the area, they're still, in numbers terms, less than 10% of the number of autonomous Wi-Fi or cellular small cells that we expect to see. So it's not such a dense layer, but still reaching large numbers. As you can see, 800,000 of these small sites to be deployed. And these will be connected to primary sites, the more intelligent hubs. This, we believe, will be the most common architecture. And we're seeing a rate of 50,000 or so of those every year being deployed, with more and more of the remote radio heads and antennas attached to them. Just a quick note on TDD, because our speaker from China Mobile, that operator, of course, has driven the interest in this technology and the ecosystem, but it's starting to become a lot more mainstream around the world as operators, again, look to the HETnet, look to harness almost any spectrum they can get their hands on to meet their capacity challenges. Some carriers looking at using TDD specifically for their separate small cell layer. Others will be harnessing it with techniques like carrier aggregation. Well, something that's interesting and perhaps shows the influence of China Mobile and some of the other big Asian carriers is that TDD is being used far more aggressively in the new architectures that are coming along. So while in sort of overall macro cells, by 2018, still we'll see 70% of the cells will be deployed in FD spectrum. When you come specifically to a Cloud RAN architecture, it's much more. There's 42% TDD, and the same in small cells, where there's 38% TDD. So still somewhat smaller, but gaining a very mass ecosystem, and very important in driving through some of the new thinking about mobile data. And just a final note, we do believe that these new architectures will largely be enabled, in the mainstream at least, by the adoption of at least some elements on the LTE Advanced, which, as you know, is a great menu of specifications and standards, some of which will be adopted and some not. But we did a survey of which of the key elements of 3GPP releases 10 and 11 carriers believe will be most important to getting returns on their network investment and supporting the capacity that they need. And it's interesting to see that the ones that they believe will be most important in the first 3 years of a new network are very much related to small cells and HETNet. The most important, they believe, are standardized self-optimizing network. There are lots of tools for this currently available, but if they're standardized, there will be more competition and more interoperability. So 56% believe that that will be critical in the first 3 years of their network. And that's followed by EICIC, which is mainly important for interference-free interworking between small cells and between layers of cells. But also coming along, as we noticed earlier, some of the more macro-driven technologies like advanced MIMO and COMP will become more important as companies start to rethink their existing macro layers. So we can see that LTE-A is being embraced, most importantly, where it can make small cells and spectral efficiency using carrier aggregation more affordable, more achievable. So far there are some cutting-edge commercial deployments of LTE Advanced, particularly of carrier aggregation technologies. They're few and far between, but there will be quite a big upsurge in them next year, and they will really start to achieve critical mass in 2015, given certain enablers, devices, of course, interoperability testing on a broad basis, and of course general confidence that the risk of deploying a new technology will meet a reward. That's it from me today. I wanted to keep brief because we've got a lot to get through, and I know everyone's waiting to hear from Tao. So I'm now going to hand over to Adeline Feller to outline a little more about the research services from Maravedis-Rethink. And while we do that, we're going to run a poll to see what your current awareness is of the Maravedis-Rethink services.
Thank you, Caroline. Good morning, everyone. This is Adeline Feller from Maravedis-Rethink, and just want to know a little more about your level of familiarity with our services here, and then also make myself the presenter here.
I've done that, Adeline.
Okay, great. So let's see, where is that? So let me close the poll here. So we have about half that are pretty familiar and half that are not so familiar. So my slides should be come handy. Can you see my screen?
Yes.
Okay, good. All right, so I won't spend much time, but very quickly, just for those that are not so familiar with us, we are a firm dedicated to wireless infrastructure, and both Maravedis and Rethink partnered about 2 years ago, to strengthen the research offering. So we have a great focus. Some of the differentiators are the first one being carrier relationships. We do talk to carriers all the time, and we have the privileged relationships with them. I think this today's webinar is a testimonial of that, and they are central to our research process, and I'll explain that in a minute. Second aspect is we have dedicated analysts for the different parts of the network. We analyze, Caroline Gabriel heads our RAN practice. We have dedicated analysts for the backhaul, the carrier Wi-Fi, another one for core, etc. And then the third aspect is what we call the real-time value, which is really support and proactive support for customers. Make sure that they get the full value of the research they're buying.
Adeline?
Yes.
Sorry, I can still only see the introduction screen.
Okay, sorry about that. Thank you. How about now?
Yeah, I can
Okay, good. Sorry about that. An important aspect of what we get from customers is how valuable is the actual data, and I think that's central to the research firm's value proposition. And so the importance of having this relationship with carriers, it means that everything starts with interviews with the operators, making sure that we are talking to the right level, CTOs, director of the RAN, the backhaul, the core, etc. Having those detailed phone interviews, and that's supported by a series of online surveys, as well as this particular webinar, for example, where a particular operator was going to provide even more details about their plans and expectations. And all of that information flows into the process. We also talk to the rest of the ecosystem, which includes, of course, vendors and regulators, and we cross-match the data coming from the operators with what the vendors are thinking. So in terms of our services, very quickly, so we have a number of services, but I will just show the top three of those services. The RAN service, we just published the latest RAN report last week. That's part of the annual service. And we do cover the RAN in its full versions, both the macro, the small cells, and carrier Wi-Fi. Again, here it's a balance between qualitative analysis and quantitative analysis, which includes forecasts and shipment information. And of course, all of that is on top of what carrier expectations and trends are. The similar deliverables for the RAN and backhaul, 2 comprehensive reports per year, research notes on different topics around the core subject, and of course analysis support. And finally, quickly, MOSA service, which stands for the Mobile Operator Strategy Analysis Service. We track top 100 4G operators, such as China Mobile, and then try to understand, what's their, wireless infrastructure strategies long term. How do we see their strengths and weaknesses, and perhaps provide some recommendations to them about the best course to take in terms of this challenging environment where there's a lot of pressure on financial pressures on the bottom lines, and while they still have to invest a lot of money on capex and test new business models. So it is a very challenging environment for operators, and so the whole structure of the survey is really analyzing, what are the drivers, and then what the challenges and what solutions derived from that. It could be either technology solutions or business practice solutions, and even regulatory innovations. And that's the whole dedicated team that manages that service. And that concludes my presentation. So if you have interest in knowing more about the services, you can reach me at contact information provided here. So now I'm moving to our next presenter, China Mobile. Before we do that, just have a few polls here on your views of certain topics that we're addressing today. The first one being about how your views about Wi-Fi. Can you see the poll?
Yes.
Okay. As a presenter, I can't see it. So let's give a few seconds for people to vote. So the first poll is about their expectations of what carrier Wi-Fi is going to be used for. See, we have a majority here of people that yes,
majority on this one.
Yeah, that's supporting data offload.
Yes, that reflects what we said earlier. The offload in the early stages is everybody's key priority before they start thinking ahead, maybe to new services.
Be sure to poll with the audience here. And, so yes. And now we have another poll, which is about about headnets in China specifically. Let's give the audience a few more seconds to vote.
Interesting one, because China is famous for having so much fibre, of course. So interesting whether wireless backhaul will be taking a role there.
Yeah, I think that question may be very specific, so we'll see what comes out of that.
Yes, I think wireless, even though the big operators are very fibre rich, but it seems the audience think wireless will take a role both for small cell backhaul and for front haul within Cloud RAN.
Okay. We'll close the poll and share the results quickly so we can move on to the next presentation. You want to comment on that?
Interesting though, small cell backhaul seems to be seen as an important application for wireless, which is perhaps not always what we hear about China, so that's interesting.
Great. I'll just push the last poll, and that's about the level of interest in innovative cloud solutions for Wi-Fi services. This is from our partner Wi-Tech, who's a leading provider of next generation of cloud Wi-Fi hotspots controllers, and have a managed service designated to create a measurable business for different market segments. So I'll provide more information about Wi-Tech at the end of the webinar. So I have still some responses coming in, and this is our last poll of the day, so you guys can enjoy the China Mobile presentation in a minute. So let me close the poll now and share the results. So yes, it seems that new innovative Wi-Fi cloud solutions are of interest to the audience. So let me hide that and make Tao presenter. Tao,
great.
Good morning.
While you do that, I'd just like to, welcome Tao Sun again. I'm delighted to have him here today, Program Manager for Network Technology at China Mobile. So thank you very much, Tao.
Please don't forget to unmute yourself.
Great. You can see the screen.
Can you see my screen?
Yes. Thank you.
Okay, maybe I can start my presentation. I'm Tao Sun from China Mobile Research Institute. And in my presentation, I will give an introduction on the following 6 aspects. The first is the commercial progress of TD-LTE, and the second is the wireless network deployment and the challenge to operators. And the third is the Nanocell introduced and the concept and the evolution. And the fourth is progress of TD-LTE Nanocell. After that, I will introduce the industrial expectations from our side, and I also give a brief introduction on the WLAN Congress in Beijing this year. The TD-LTE already came into commercial stage worldwide. There are 18 TD-LTE commercial service launched globally by the first half year of 2013. There are many operators has launched such service. By the end of the year 2012, there are 50,000 TD-LTE base stations deployed globally. And by the first half year of 2013, there are 200 modes of TD-LTE terminals launched, and most of them are data cards and LTE-CP or mobile hotspot. 29 smartphones. Also, by the first half year of this year, 3.6 million TD-LTE custom developed already. There is global TD-LTE initiative organization to promote the TD-LTE deployment. By the first half of this year, it has developed 56 operator members and 54 vendor partners. For the TD-LTE deployment in China, maybe we can have a brief review on that. In the last year, we have two stages. The first is the large-scale trial that lasts from 2010 and 2012 May. There are 7 cities and 1,000 base stations. For the second phase of the trial, we have enlarged the trial scale from July last year to June this year. We have tried 10 cities and deployed to 20,000 base stations. In this year, we from the previous phase, we further accelerate the pre-commercial service. The deployment will be larger than 100 cities, and there are more than 200,000 base stations deployed. Well, with the above, we want to analyze the wireless network deployment and the challenges to operators. We think the data traffic burst cause serious challenges to operators. So thanks to the extensive use of smartphones, pads, and laptops, the wireless data traffic is exploding. As we can see that in the previous 2 years, the wireless data traffic increased dramatically in our network. So the operators have to face serious challenges. For example, the network capacity versus traffic load growth, and the CAPEX, OPEX rise versus the revenue slowdown. So the challenge on network deployment from our side, we see some challenges such as the public awareness of electromagnetic radiation protection, and also after the introduction of TD-LTE, the station construction with multi-system and multi-band need to be considered. For example, we need to consider the GSM, the TDS, CDMA, and the TD-LTE. The site selection and construction versus the accurate traffic distribution is also another challenge. The indoor scenarios is more complex, and it's hard to construct, even hard to construct versus the large.
Tao, sorry to interrupt you. It seems like the audience cannot see your slides. On top of your screen, you have to press show my screen. I mean, I can see them, but for some reason the audience cannot see them.
Is that okay now?
I mean, I can see them, but hopefully, give me a second, please. Here, I'm going to see. If, no, they still can't see your slides for some reason. Perhaps we should. Let us try to solve this issue. Otherwise, there
are several people in the audience saying they can see them fine.
Oh yes. Okay.
Yeah, I've got several people on the question box.
In any case, this event is recorded, so for those who cannot see, we apologize and make sure that everybody can see the screen. So please continue, Tao. Sorry for interrupting.
Okay. Also, we meet the challenge of lack of efficient indoor coverage scheme. Existing schemes such as the micro-base station, it has advantage such as wide area coverage and without indoor construction, but it has large penetration loss. Also, it need to share capacity with outdoors. Also, the capex is high. As for the distributed antenna system, it has guaranteed signaling, but it's hard to support a feature such as MIMO and also need indoor constructions, hard to split for capacity increase. Also, the capacity capex is high. So we see this, the challenge is even worse to support LTE, because LTE, we may use high frequency band, and the UE capacity is also high. So that's what the difficulties we met. So we introduced the nanocell concept and to view it as an important approach to solve the challenge. As we know that small cell and wireless LAN are considered as effective and low cost and broadband wireless coverage solutions. As for the cellular network, it can achieve architecture will transform from microcell to small cell to that. Since small cell is one way to improve the wireless network capacity, in view that there are three major factors to increase the capacity of the network. That is the new spectrum, the spectrum efficiency, and smaller cells. So we think that smaller cell is one important factor to improve network capacity. As for the wireless LAN, as we all know that it's a low-cost wireless broadband access technology, and its access speed also increased in the past years, as from 20 megabit per second to around several hundred megabit per second. As you know, that China Mobile has made big effort to wireless LAN network construction, and we deployed more than 4 million wireless LAN APs up to now, and maybe the number will increase 6 million in the next two years. So it's natural for us to integrate a small cell with wireless LAN to further increase network capacity and reduce network capex and OPEX. So we introduced the nanocell as a type of base station integrated with small cell. The mode of nanocell may include 2G or 3G, and it can be single or multi-mode. And the major feature is that it's integrated with carrier-grade wireless or wireless LAN AP. There are 5 major key features of nanocell. The first is it's a common platform integration with carrier-grade wireless LAN and cellular network. And the second is to support co-coverage and interference collaborations between cellular system and wireless LAN. This can reduce coexist interference and guaranteed coverage and capacity of the two systems. The third is it supports flexible and low-cost backhaul link transmission. So the nanocell can support wired and wireless backhaul network. The fourth is it has low capex and OPEX. We aim at the SoC-based architecture to achieve this. And the last, the nanocell is a complete and trust security solution. So that's the major features of nanocell. As for the nanocell, we view the evolution roadmap as that it's integration of small cell and wireless LAN network. That is the two separate network to one single element. to build the single box that provide both cellular and wireless LAN service. And the Nanocell may also evolve in future to incorporate more new features such as LTE advanced in the cellular part, and also the wireless LAN module. We can also incorporate new features such as hotspot 2.0, something like that. Then I will give some brief introduction on our progress of TD-LTE Nanocell project. In August last year, China Mobile Research Institute released the first version of Nanocell technology white paper, and this white paper give our requirement and the vision of the Nanocell technology, and we signed a MOU agreement with 7 companies from small cell industry to cooperate on key technologies, research and product R&D and lab testing and trial. In the first half of this year, we have done the Nanocell lab testing, and in the second half of this year, we have done EPCR interworking test, and we also did the Nanocell gateway lab test. Currently, we are do some field trial of Nanocell in some cities. For the Nanocell, we have 2 providers up to now can be used in the field trial. That is one from ZTE, another from Comma. They provide us the enterprise Nanocell. For the LTE parameters, it supports 3GPP release 9 features, and also it supports some features such as 10 or 20 megahertz bandwidth. For the wireless LAN parameters, it supports multi-mode of wireless LAN. Also, it supports 2.4 and 5.8 gigahertz band. The physical parameters is this device is about 2 literate or 3.5 literate. The weight is around 2 to 3 kilogram. In our testing, we have do some basic function verifications, such as the synchronization. We use the IEEE 88 version 2 GPS and OTA synchronization approach, and we also use did the interference testing, since the interference is the main factor affecting the Nanocell performance. It suggests to use walls as natural isolation scheme and use RCSA function to improve the network performance. We also tested the installation and maintenance to verify the basic SON features, and all such as the self-start, self-configuration, and ANR. And we did some mobility management tests, such as the cell selection and handover. From the gateway and the network side, we also did some testing, function testings, such as basic functions, such as attach, handover, service request, direct create, or release, and the mobility-related things. For example, the S1-based handover and inter-gateway handover, and those session management functionalities. We have do some authentication. The EAP archive authentication is tested. We also requires the certificate-based authentication. And both the nanocell management and the nanocell gateway management have been already tested. In our test, we use the nanocell gateway. That here it's we select one of the three predefined architecture for the gateway. That is the signaling will integrate it into the gateway to approach the MME, while the data part will be directly bypass the gateway. As we see the nanocell as a key technology, so we have some expectations on the nanocell support from industry. The first is for the key technologies, we think a low-cost and high reliable solution on synchronization, power consumption, and wireless LAN integration are important. We also view the SON and the interference coordination for large volume deployment is important. By the way, the effective local IP access solution is also important because it can provide some local access to, for example, enterprise scenarios. We also want to get industrial support to accelerate commercial SoC and TDD protocol stack roadmap to lower the technical barrier to nanocell equipment research and development. We hope more vendors to support our TD-LTE product. Well, as we know that the nanocell is the integration of small cell and wireless LAN AP, so the standardization of the wireless LAN AP and AC interface is important to do the interworking among between different vendors. The third thing we want to have is for the easy deployment feature of nanocell, because it needs to optimize the we want to optimize design to share the backhaul power supply and the site, etc. With legacy wireless LAN system, and we also want to have reduced the equipment size and power consumption to improve product ease of use and wide applicability to decrease small cell network capex and OPEX. So that's the brief introduction of nanocell. Well, in the end, I would also to mention some WLAN Congress in Beijing. For the WLAN, because as you may know that it is wireless LAN broadband alliance. Its aim is to secure an outstanding user experience through the global deployment of next generation Wi-Fi, and its membership include major fixed operators and also 7 of top 10 mobile operator groups and the leading technology companies. And China Mobile is also on the WA board. We have contribute to WA. As you know, this year WA have a project on the small cell and wireless LAN integration, cooperate with small cell forum, and we think that project is a good way to achieve some of our visions on the nanocell. And I also hope we would like to invite you to Beijing this November to attend the WA Wi-Fi Global Conference event. There are some information available on this WA Broadband Alliance Congress, because China Mobile is hosting this congress. So that's all my presentation. Thank you.
Thank you, Tao. Caroline, back to you. I'm gonna just show my screen while you run the questions. Thank you.
Sure. Yes, thank you so much, Tao. That was really interesting and detailed. Great to hear more about the Nanocell project. We've got various questions, which I will hopefully we'll have time for 2 or 3. First, does the Nanocell work with the macro layer or with the Cloud RAN? Is there interaction between the layers? Did you hear that, Tao?
Oh, okay. For the Nanocell, for the Nanocell, we think it's combined with Cloud RAN. We think it's important approach in scenarios such as the indoor coverage. So the Nanocell can work together with Cloud RAN, because Cloud RAN is major on the microcell. I think you also mentioned that in your previous presentation. So yeah. So we think that those two solutions are important in our view.
Also, will the Nanocell be used outdoors?
Maybe in some scenarios in future, but at least at present we think we position Nanocell as major used for the indoor coverage.
And for small cells outdoors, will you use wireless backhaul, or do you have fiber to every site?
For the backhaul, as I have mentioned, for China Mobile, we have the advantage that we have relatively good backhaul infrastructure. We have deployed many wireless LAN APs, so those wireless LAN AP backhaul can be reused by the Nanocell. So the wired network, that is major the PON, GPON or EPON, and the PTN may be the major backhaul for the Nanocell. But we also think the wireless line backhaul can be another alternative in scenarios where those wired backhaul is not available. But the major part will be the wired line backhaul.
Yes, I understand. That's interesting. There was one question actually which I think was directed to my presentation, which I'll quickly answer also. A couple of people were asking about the difference in the Cloud RAN between what we described as primary sites and sub-sites. We do see this from our studies of carrier plans as being quite an important distinction, but basically the primary site links directly to the cloud server or the base station hotel, and has quite rich functionality. That will usually be a radio head incorporated into an antenna. Then that will support a sort of fan of coverage with much smaller, much more simple, very small sites attached to this, with the main site acting as a hub. So it won't be everybody's architecture, but we're seeing increasing support for that idea. I think there have been a couple of carriers that have already showed it off, but it's one for a couple of years' time, but it enables to get very extensive coverage with some extremely low-cost cell site equipment at those sub-sites, which potentially over the years will come down to being $100 or so in cost. So it's an architecture that we believe will be adopted by some carriers where appropriate. So I thought I would fill that one in. And I think a final question, please, Tao. Tao, what is China Mobile already trialing TD-LTE Advanced? Is that on the roadmap?
I think the TD-LTE Advanced is shown in the roadmap, but in some testing we have done some testing on some of the features.
Great. So that's on the horizon. Because obviously we've seen a lot of interest in the features of Advanced. Most of that so far has been in FD.
Yes, right. Because even for the Nanocell itself, after this year's progress, in the next we may also incorporate some LTE advanced features into Nanocell.
Great. Would that be carrier aggregation or
right.
MIMO?
Yes.
Yeah, a mixture of those. Great. Well, that's looking forward to the next generation. That seems a good point. We've covered quite a few of the topics. Apologise if we didn't cover your question, but I hope that perhaps we can engage with you on that offline. But for now, I'm going to hand back to Adeline for a final word. But before that, I would like to thank once again Tao Sun for a really interesting presentation and for spending the time today, and thank all of you for your time and for attending. I hope you found it valuable.
Yes, thank you, Tao and Caroline. Just a few words before we leave. Important announcements. Tao has mentioned the WBA meeting in Beijing, which we fully support. In fact, we will be doing a special free webinar with the WBA on November 26 to present the state of the market for carrier Wi-Fi, a study that we conducted in collaboration with the WBA. So that webinar is free. Everybody is welcome to join us November 26. I also would like to invite all participants to fill out the very short survey at the end of the webinar to let us know how we can improve our webinars, either in terms of content or way to deliver the message. So we appreciate that. I also wanted to thank our media partner Cloud4Y for their support in this webinar. There's information here about their cloud solution that I invite you to reach out to them if you're interested in knowing more about what they do. And that's pretty much all for me. So I want to thank again Tao for his excellent insights. And for the questions we haven't answered, we will follow up with you specifically. Thank you, Caroline. Thank you, Tao.
Thanks, everyone. Goodbye.
Thank you. Bye.
Thank you. Bye-bye.